Hello everyone, welcome back to my channel. So far in previous lectures we have discussed what is operating system, what are the functions, types of operating systems, basic structure of operating system, and also the basics of operating system like computer operations, storage structure, IO structure, etc. In the series of lectures of operating system, the computer system architecture, this computer system architecture in an operating system is the design of a computer hardware and software, which includes the CPU, memory, and input output. It also includes how the components communicate with each other, that is shown in the computer system architecture. Now in this lecture we will understand what is single processor system, multiprocessor system, and clustered system. And these single processor, multiprocessor, clustered systems are categorized based on the number of general purpose processors used. As the name suggests that single processor system. Single means only one main CPU which is capable of executing a general purpose instruction set including the instruction from user processes. Whereas there is a special purpose processor, right? Other special purpose processor means in system we are having only one main CPU, and that main CPU is capable of executing all the general instruction set from the user processors. But coming to the device specific task, like we are performing IO task or we are performing the memory task, that time we need a special purpose processor, and that special purpose processor is also present in this single processor system. That single processor system takes care all the user processes, that is called the main CPU, but the special purpose processor will perform the device specific task. Device related tasks are performed by this special purpose processor. Most oftenly we find laptop, computer, standalone system, all are having a single processor systems, right, which can capable of performing a single task at a time. Whereas the second type is the multiprocessor systems. So as the name suggests, multiprocessor means more than one processors. We might be having 2 or 3 or n number of processor, which is also called as the parallel systems or tightly coupled systems. It has 2 or more processors in close communication and sharing the computer bus, sometimes the clock, memory, and peripheral devices. We have already seen in our second lecture basics of operating system. When we are discussing the computer operations, that time we have already discussed the computer bus or the system bus. So all the devices are communicating with the common bus which is called system bus. So the processors which we have in the multiprocessor systems, they can closely communicate with each other and share the computer bus commonly and all the peripheral devices, memory, etc. We have three major advantages of using the multiprocessor systems. The first one is increased throughput. By increasing the number of processors, we can expect to get more work to be done in less time. That is the major advantage and the major benefit of using multiprocessor system. So increased throughput means we can do more work in less time. So we can get more processes to be done in a lesser time. So that is the major advantage. The first one is increased throughput. So we can increase the number of processors, means 2, 3. If we are increasing the number of processors, we can expect to get more work to be done in a less time, because more CPUs are working means more processes can be done in a lesser time. So this is the first advantage of multiprocessor system. Second is economy of scale. When multiprocessor system can cost less than the equivalent multiple single processor systems. Assume that we have 10 single processor systems. So every system is having their own peripheral devices, memory, clock, registers, etc. Right? But what happened when multiprocessor system is used, and in multiprocessor we are having n number of processors. N number of processors can share a common peripherals, common storage, memory and power. Hence we can reduce the cost of the operation. So therefore we are having a economic of scale. Scale means we can get many peripheral devices, memories, bus, etc. to communicate with each other. So if we compare to the single processor systems, multiprocessors are beneficial. So therefore it is an economy of scale. The third is increased reliability. If function can be distributed properly among several processors, then the failure of one process will not hurt the system. Only it can slow down a bit, but it cannot halt the system. Means in single processor, if we assign any task and that task means that processor get failed, our task will not get performed. But in multiprocessor systems, even though one of the processor get failed, then also we can able to complete our task. That gives us the reliability. So we can get more reliability in the multiprocessor system. So increased reliability is there in the multiprocessor system. So this increased reliability of a computer system is crucial in many applications, because in real time operations, there is a real time operating systems, we must have the multiprocessor systems, because the time is very crucial for those applications. So therefore we can have more processors. If one of the processor gets failed also, our process will get complete. Okay, right. So this is the multiprocessor system. In the multiprocessor system, we have two types. Some system use asymmetric multiprocessing, and some multiprocessor system use symmetric multiprocessing. So let us understand what is mean by symmetric multiprocessing and asymmetric multiprocessing. So the most common system which we use in the symmetric multiprocessing, in which each process performs all tasks within the operating system. Means now you can see there is a CPU 1, CPU 2 and CPU 3. It means that each processor perform all tasks. Means every processor can perform all the tasks P1, P2, P3. There are 3 tasks we have, and we have 3 CPUs also. They won't distribute their work. CPU 1 will perform some operations of P1, and CPU 2 also performs some operation of P1. CPU 3 also performs some operations of P1. So in this fashion, all processors are working like a peers. There is no master slave relationship exists between the processors in symmetric multiprocessing. Whereas in other side, if you see, there is a master slave category is there in asymmetric multiprocessing. One is a master right? One is a master processor controls the system, and the other processor either look to the master for the instruction or have a predefined task. Those are slaves, right? So slave can have predefined task, or they are waiting to get the instruction from the master. So if master assigns some task, say P1 is assigned for slave 1, P2 is assigned for slave 2, P3 is assigned to slave 3, like P1, P2, P3 are assigned to slave 1, slave 2, slave 3. Assume that slave 2 is not working now. What happens? A P2 will not get executed, so it will wait for the master to choose either slave 1 or slave 2 to perform this operation. So who will decide? The master processor will decide, because master processor controls the system. The master processor schedules and allocate the work to the slave processors, because master processor is working like a boss, slaves are like a employees. So whatever the work is assigned by the boss, that work has to be performed by the employees. Similarly, the employees are nothing but the slaves. So slaves has to work whatever the work assigned by the master. Okay. So I hope you understood the difference between symmetric and asymmetric. Right. So coming to the third category or the third type is the clustered systems. Like multiprocessor system, clustered systems gather together multiple CPUs to accomplish computational work. Means in this, what happens? A cluster system gather together multiple CPUs. Multiple CPU means you can see in the figure there is a computer 1, computer 2 and computer 3, right? So computer 1 is having a CPU, this one is having a CPU, say number 2, this is number 3. Like this we have gathered all the 3 CPUs together, right? So multiprocessor systems, clustered system gather as like a multiprocessor system is having multiple processor in a single system, whereas the cluster system gather together the multiple CPUs to accomplish the computational work as like a multiprocessor system, right? So as multiprocessor does the multiple tasks at a time, similarly the cluster systems also performs the multiple tasks at a time by gathering together the multiple CPU, which is commonly get connected via local area network, right? So cluster systems share the storage and are closely linked via the local area network, that is LAN. So the cluster system also differs from the multiprocessor systems. However, in that they are composed of 2 or more individual systems coupled together. As the definition say, clustered system. Clustered system means we are gathering the different systems together and performing the task as one. Okay. So therefore the cluster is usually used to provide the high availability of service. That is, service will continue even if one or more system in the cluster gets failed. Then also the other systems are available. That's what we say that high availability is obtained in the clustered system. Now here high availability meaning is, as I said, if assume that computer 1 is not working, other computer can work, other computer can perform the task. That provides the high availability, okay, and can be structured. asymmetrically and symmetrically. So this clustered system also having the structure like asymmetrical and symmetrically. Now what is the meaning of this? Asymmetrically means one machine in hot standby mode, right? A hot standby mode. The meaning of the hot standby mode is while the other is running the application, one will stand as a hot standby mode. The hot standby machine does nothing but monitor the activity of the server. That is the purpose of hot standby. Standby meaning is it doing nothing, but it is monitoring, right? It is monitoring the activity of the server. If assume that the standby machine which is monitoring the server, right? One machine means one of the computer is monitoring, and assume that other system gets failed, right? If other system or server get failed, the hot standby host becomes the active server. In most of the time what happens, assume that this computer 1 is a server and second computer we are making it as a hot standby HS. Okay, now what it is doing, the computer 2 is continuously monitoring the computer 1, the server. If assume that if server gets failed, the privileges what the server is having is assigned to computer 2. Now this hot standby machine becomes the server and all other computers can run their applications as usual, right? So this is how this term asymmetrically is used. Okay, symmetrically means what? Two or more hosts run the application, right? Two or more hosts run the applications. It means that in asymmetrically nobody is on hot standby mode, right? Nobody is on hot standby mode. All the machines, if we are having two or more hosts, those will run the applications. They will not monitor anything. They will not be made hot standby machines. So this is the difference what we are having in the clustered systems. So far we have discussed these three types of computer system which is classified or categorized based on the number of general purpose processors used. Single processor systems which using the single processor, multiprocessor systems which using the multiprocessors, and clustered systems are nothing but the systems are gathered, different systems are gathered connected via local area network to perform multi-programming task and working like a multiprocessor systems. So this is so far what we have discussed in this lecture. So thank you for watching. Like, share and comment. Thank you.